Hi everyone, this is Dr. Chukka Santhaiah, Associate Professor of Computer Science and Engineering Department in Institute of Aeronautical Engineering, Hyderabad. Today we discuss about the decision tree learning. The decision tree learning has three words: decision, tree and learning. We make any decision based on some conditions or based on some rules. That decision is represented or indicated in tree format. Based on that, we can learn something. That is meaning about this, general meaning about the decision tree learning. Means we collect some databases or data sets. Based on the data sets, we make some decision based on some conditions or rules. That decision may be represented in tree format. Then it is based on that tree format, we try to learn which one is good or which one is bad, or which one is positive or which one is negative. We can learn something based on the tree representation. That is called decision tree learning as a general meaning about that. But in machine learning, what is the meaning about the decision tree and how it is, what are the various components are there in the decision tree. Decision tree is a supervised learning technique. Means decision tree is a one type of technique. That technique comes under the supervised learning technique. In machine learning types, three types are there: supervised learning, unsupervised learning, and reinforcement learning. Means so this decision tree comes under the supervised learning technique. Means it is a learning technique that comes under the supervised. Whereas supervised is nothing but we make some decisions under some supervision. Means we have some idea about the input as well as output. That is meaning about the supervised learning technique. So what it contains in the decision tree? It can be, the decision can be used for both classification and regression problems. Means it can be used for both classification and regression problems. Means based on the decision tree, we can solve the problems that is about the classification problems as well as regression problems. But mostly it is used for the classification problems only. But the decision tree supports both problems, classification problems as well as regression problems. But when it comes to the most of the decision tree can be used over the classification. Means classification is nothing but we divided important as well as unimportant. Means for example, come to our email services. In email, there is inbox is there, or primary message, or inbox is there, as well as some spam is there. So whenever the message can be, whenever the mail is received, the mails, it is important for the mail or personal mail, it goes to the automatically sent to the inbox. Or maybe other mails maybe goes to the business or maybe advertisement purpose, it goes for the spam. Means internally it is classified, either it may be important or maybe not important. Means personally or maybe advertisement or maybe somewhat commercialized. That is thing about the decision. Means classification. Whereas come to the regression problems, means we have some continuous data. Based on that, we can do some classification. Based on that, we can find some resultant in the classification in the regression problems. Right. Decision tree is a tree structure format or tree structure classifier. Means it is a tree structure classifier. Means it has some shape in the form of the tree structure. And internal nodes represent the features. Means the tree structure is contains the internal nodes. Means it has some internal nodes. Means first it is contains the internal nodes, and the second one is it contains some branches. Means about the second one is branch, and third one is it contains the leaf nodes. Means about it is called the leaf nodes. Means third one is it contains the leaf node. Means this a decision tree is a tree structure classified. It contains three parts: internal node, branches as well as leaf nodes. Whereas come to the internal node represents the features of the data set. Means about this internal node represents features of the given data sets. Means that internal node is represents features of the data set. Features of data set. Whereas come to the branches, means branches represent the decision rules. Means this branch is represents decision rule. Whereas come to the leaf node, means about the LN, leaf node. It is outcome of the input, outcome of the data set. These the three things are there. Three parts are there in a tree structure. They about the decision tree learning. Means this decision tree is a tree structured learning. Means it is a tree structured classifier. It contains three components: internal node, branches, as well as leaf nodes. Here this internal node as well as branch and leaf node have their specific representations. That is about the internal node is represents about the features of the data set. And the branch is represents about represents the rules based on we make some decisions that is contains some rules. And leaf node is contains it is represents the outcome of the data set. That is thing about the tree representation about the decision tree and three parts as well as three parts representation. Means it is contains three parts. First one is internal node. That internal node is represents about the data sets of the features of the data set. Second one is branch. It contains the rules, set of rules to make some decisions or conditions. And leaf nodes is contains about the outcome of the decision tree or outcome of the decision node. And in a decision tree, there are two nodes are there. Two important nodes are there. First one is decision node as well as leaf node. Means the decision tree is contains two nodes, two important nodes. The first one is decision node. Means first one is this decision node. And second one is leaf node. Two nodes are there in decision tree. Means the decision node is name indicates name, decision. It makes some decision based on the data sets or based on the given data set. Whereas come to the leaf node is the outcome of the decision node. Means whereas come to the decision nodes are used to make any decision and have the multiple branches. Means the main theme about the decision node is to make some decision and there are some multiple branches also. Whereas come to the leaf nodes are the output of the decision, output of those decisions and do not contain any further branches. Means the decision node is mainly represents make some decisions as well as there are some multiple branches. Whereas come to the leaf node, it contains the output of those decision nodes and there is no further extension, there is no further branches. That is thing about the data decision tree nodes. First one is decision node, second one is leaf node. Whereas come to the decision node is especially make some decisions and has some multiple branches. And then leaf node. The leaf node is outcome of the decision node and there is no further extension or there is no further branches or further leaf nodes. That is thing about the two nodes are in the decision tree. Right. The decisions are tests are performed on the basis of the features of the given data set. Means the decisions are made based on the features of the given data set or maybe features of the input data set. That is thing about the means finally decision tree is a tree structured classified. It has some internal node, branches as well as leaf nodes. And then the main decision tree is mainly two nodes are there. First one is decision node as well as leaf node. Whereas come to the decision node is make some decisions as well as it has some multiple branches. Whereas come to the leaf node, it contains the leaf node is represents the outcome of the decision node and there is no further extension as well as there is no further branches in the leaf node. As well as the decision takes based on the features of the given data set. Right. And it is a graphical representation for getting all possible solutions to a problem or decision based on given conditions. Means whenever it represents the graphical representation, the decision tree, it is provided some all possible solutions or problems based on the given conditions. Means it produces some conditions, it produces some solutions or possible solutions to the problems or maybe decision and make some conditions. Right. So it is called decision tree because similarly to a tree. It starts with the root node, with expands on further branches and constructs the tree-like structure. So it is called decision tree because it is like a tree format. And it starts from the root node. Means for example, we can take it is a tree as well as it is a subnode. Means sub-chain nodes. Or subnode. Means it is how start from the root node. This is called root node. Means it is called root node. And you can further extension based on the conditions and like a tree structure like this. Like this. Here also like this. Like this. Here also like this. Here also like this. Tree structure. Means that is simple. And in order to build a tree, means we try to build a decision tree, we can use the CART algorithm. That is, it stands for the classification and regression test algorithm. Means to build a decision tree, we use the CART algorithm. The CART is nothing but a classification and regression test algorithm. Means we try to build any decision tree, we must follow the CART algorithm. Classification and regression testing algorithm. As well as the decision tree simply asks the questions and based on the answers yes or no, it further splits the tree into subtrees. Means the decision tree simply asks some questions and makes some questions, ask some questions and then express some answers, either maybe yes or no. Based on the answers, it tries to split the branches, branch or tree into subtrees. For example, once again take some example here itself. This one is root node. This one is child nodes. Means about it is a left child as well as right child. Here we can go to some condition. Means, for example, here is the some condition. This is about the 2 value. This value is 2. And this value is 5, for example. So, we need some condition. We can split it. Means, if you can take some input value, that is about the 1, 3 in the first left node. So it is condition 2. So if you have some condition, you can further extension. Why? Because if 2 is there, is a root node or maybe a decision node, here 2 inputs are there, either maybe 1 as well 1, 3. So based on these 2, which one is less than 2 value, there is a root node, it goes to the left side. That is about the 1 condition. Means further extension or further splitting. And then we are going to the sum means about the here. Which value is, which number is the highest value? It is of 3. So it is go for the right side of the root node. That is about the 2. Means again we go for example, we had one more input. 4 is there. So again, which 4 is the greater than the 2 value. So automatically it goes for the 4. Why? Because it is right side. Further splitting as well as further expansion based on the some conditions. Either yes or no. Means we take some 2 inputs, 3 inputs, 1, 3. It is a 2 become as a root node. So which value is the less than the root node? It is goes to the left side. Means less than or greater than some condition. It goes for the splitting. As well as 3 is the greater than the 2. So it maybe goes to the 3 value. Means about the 3. Why? Because it goes to the 3. Means right. Means it is greater than the 2. So automatically goes to the right side of the root node. That is about the 2. Again, one more input value is there. That is about the 4. If 4 is also, this 4 is also greater than 2 and as well as greater than 3. So it goes for the left side, the right side of the tree node. But when you observe this one, 5. So when you check this right side node, the 5, these all are less than this value. Why? Because this goes to the left side only. That is condition. Based on that, we can splitting the tree. It is answers yes or no. Means making some conditions, then we can check it. That is in the body. Means we decision trees ask some questions. Based on the yes or no, you can go to further extension or further classification. That is further splitting of the tree. It becomes a subtrace. Right. What is the structure of the decision tree? Means decision tree is, we can observe whenever you can observe this figure, we have some idea. Orally means when you check it, some decision node starting, that is about is called root node. This is about the root node. And decision node from the left side, another decision to the right side. In the left side decision tree, means leaf nodes are there. Leaf node, left side is one leaf node, as well as right side is the another leaf node. Whereas come to the right side decision node, it has some leaf node in the left side, and right side again one more decision node is there. In this decision node has some left child as well as right child, means left leaf node as well as right leaf node. Means we are only one condition, means final output. There is no further extension. So decision making and then it will come as a final output. This is about the leaf node. Means there is no further extension. But it is become as a some separate tree. Means about some completely goes to the separate subtree. Why? Because it has root decision node as well as leaf nodes. The subtree. Again we come to the here also. Here also we have some subtrees. Is about the, it is one type of one subtree. Whereas come to the some other clarification, as well as we can go to it is on means another subtree. Means whenever we can observe this one, so automatically we can go to the decision tree. Means the decision tree has some decision, means the tree has some root node. This is about the start from the root node and divide into further splitting based on conditions. It may be a subtree or maybe splitting. So whenever we discuss about this node, decision nodes as well as root nodes as well as leaf nodes, the root node is nothing but it contains the entire data sets or features about the data set. Whereas come to the decision node, it contains some conditions, make some decision either less than or greater than, either positive or negative. So then we can classify it. And then it is reached the final node. Final node means about the leaf node. There is no any further extension. When you observe this one, this left side subtree, there is no further extension. Why? Because leaf node is this side as well as leaf node is this side. Only it stops there itself. There is no any further extension. Why? Because this is the final node. It is called output or leaf node. Means decision node. Whereas come to the right side, again we can check it. Decision node is there as well as one more decision node is there. But whereas come to the this one, means about the here we left first decision node. Here is right side the first decision node. Node has some, left side has some leaf node. It is stopped there itself. There is no further extension. Whereas come to the right side, it is again one more decision node. This leaf node as well as leaf node. So this means whenever we can start it is leaf nodes means root node, it is further extension based on these conditions, various conditions. And in decision node is finalized decision. And then it can be used either leaf node or only decision. Means whenever it is the leaf node is constructed, there is no any further extension as well as there is no further splitting about the tree. That is thing about the decision tree. Right. Next, why we can use the decision tree in machine learning algorithms or in machine learning approaches? There are two problems, two key things are, key aspects are there, two key reasons are there to use the decision tree. Means there are various algorithms in machine learning algorithm. So which is the best algorithm for the given data set and problem in the main point to remember while creating a machine learning model. Below the two reasons for the using the decision tree. Means main two reasons are there why we can use the decision tree. First one is the decision tree is usually mimic human thinking ability while making decision. Means the decision tree is usually mimic means behave like human being. Mimic means behave or think like a human being. Means behave like a human being, thinking ability to make some decisions. As a human being, we can take some two objectives, means two inputs. Means for example, take some two numbers. The two numbers is 2, 3, for example. Two inputs. Means two. We have some idea. Means 2 is one number as well as 3 is another number. We can make, means which one is the highest number? We compare with 2, 3. So automatically 3 is the highest number. Which one is minimum value? 2. So automatically we have some idea. Numerical numbers means 1, 2 up to some limit, some limitation, some numbers. As well as we can take about the 4, 5, 6 as well as 16 as well as 6, 7 as well as 8. From this we are select the which number is the highest value. We have some idea. We can automatically select S16 is the highest value. Why? Because we can check it. But whereas come to the 7 and as well as 8 and 4 as well as 5. Which one from this input values, which one is the least value? Means lowest value. 4 is the lowest value. We have some idea. Means Whenever we can assign any task to the machine learning means about the decision tree. It is also make you think like a human being, behave like a human being, and make some decisions. So it is easy to understanding. Why? Because tree representation. It represents and it is creating some solutions. Right. Right now. Next, second reason for the using the decision tree. The logic behind the decision tree can be easily understood because it shows a tree-like structure. Means, is a logic behind the decision trees can be easily understanding. Why? Because it is a tree structure. Means, we can easily understanding the decision tree outputs or decision tree representation. Why? Because it represents about the tree. Means about the automatically check it. Is a root node. It is a root node as well as left side, right child, as well again one more node, as well as left and right, means automatically you can easily understanding. They automatically think it is a root node, means about the it is a root node as well as some other decision node, as well as these are the two leaf nodes, means easily understanding. Why? Because it is a tree structure. So based on these two reasons we can use the decision tree in machine learning. First one is it is mimic like a human being and make some decisions correctly, and it is easy to understand. And is there any logic is there behind is this one? Means easy to understand. Why? Because it is tree representation. The layman is also can understanding. Why? Because some numbers is goes to here as well as some represented tree representation. It comes on the left side as well as comes on the right side. So automatically it has some decision to easily understanding. Based on these two reasons, we can use the decision tree in machine learning. Whereas comparing the other algorithms, right? Next, we are discuss about what are the keywords are there in decision tree. Means in the keywords, first one is root node, second one is leaf node, third one is splitting, fourth one is branch or subtree, fifth one is pruning, sixth one is parent or child node. These are the nearly 1, 2, 3, 4, 6 keywords are there. In between, one more keyword is missing. That is about the decision node. So, in between the leaf node as well as in between the root node as well as leaf node, one node is represented, one more node is there. That is about the decision node. That is missing. So, the decision node is make some decisions based on some conditions. And what is the various things are the various keywords are there about the decision tree. First one is root node, second one is leaf node. Means root node is a starting node. Root node is a starting node. Whereas come to leaf node is a end of the tree representation. Or end node of the decision tree. Right. Root node is from the where decision tree starts. Means root node is nothing but where the decision tree starts. It is called root node. And it represents the entire data set. Means root node represents the entire data set, which further gets divided into two or more homogeneous sets. Means we can root node starting from the decision tree start with the root node, it contains the entire data set. And it goes further extension, further divided into some more homogeneous tests or more homogeneous sets. Next, leaf node is the final output node of the decision tree. And the tree cannot be segregated further after getting the leaf node. After getting a leaf means the leaf node is a final output node of the decision tree. And there is no any further extension. And there is no any further nodes. Or there is no any further splitting after reaching the leaf node. That is about the leaf node. Next, splitting. The splitting is nothing but a division or maybe segment. The splitting is nothing but a dividing or maybe segmentation. Means the splitting is the process of dividing the decision node or maybe root node into subnodes according to the given conditions. Means we have some data sets and we can try to divide the trees into subtrees. That is called splitting. Means splitting is a process to divide the root node or decision nodes based on some conditions. Means one more thing, I can give some example about yourself splitting. For example, we can take some databases, some data sets. That is about the 2, 3, 4, 5, as well as 6, 7, 8, and 9. So, nearly how many data sets are there? 1, 2, 3, 4, 5, 6, 7, 8. Again we go to the 10th one. Means okay, one more thing. What about the 10? Really? 6 is there. Means from this we are select the best one. Means we are select the best one. Means about the we select the root node. Means we are select the means root node is a 5 in case. Means we are randomly means we are select the some based on conditions. It is 5 is the root node. Means here 5 is there. It is the root node. I can automatically have some condition. Means which value is less than 5, there comes under the left side, as well as which value is greater than root node means about the 5, there goes to the right side. There is some condition here. Means here 5 is the root node. From that root node we are dividing. Means we are splitting. Means 5 number is a root node. Which value is less than 5, there comes under the left side. Means condition. Less than means comes under the left side. Greater than the 5, root node means comes under the right side. Again we can check it. Means so when you compare this one 2, 3 as well as 4. So automatically 2 and 3 as well as 4. When you observe this 4, 3, these are the less than 5, automatically comes on the left side. Again one more parameter, one more thing is there here itself. That is about the 2, 3. Means is the right side. Why? Because 2, 3 is greater than the 3. Sorry, 3 is greater than the 2. Again 4. It is also right side to the 3. Why? Because 4 is greater than the 3. Again we go to somewhat. Means next 6 is greater than the 5. So automatically go to the right side of the root node. Again 7 is there. Again it is greater than means about the its right side. And we go to the somewhat 8. Sorry, here it is also 8. 8 is also greater than. And 9 it is also greater than 8. And 10 it is greater than the 9. So when you observe this figure, automatically some condition there. Means we are select the one root node and follow some condition. Means less node values, less values comes on the left side of the root node as well as highest values to the right side of the root node. Means some condition. Means we are further splitting about this one. Automatically we can check it. So that is the thing about the splitting process in the decision tree. We can take one more example. We can discuss about randomly we can take it. But when compared with simple example, for the easily understanding purpose, I can do something. Right. Next, one more good keyword about the decision tree is branch or subtree. Means the branch or subtree is a tree formed by splitting tree. Means either maybe branch can be generated or maybe subtree is generated by the splitting the process. Means previous one. It may be branch or maybe subtree. And the next one is pruning. The pruning is the process of removing the unwanted branches from the tree. Pruning is nothing but elimination. Or pruning is nothing but avoiding and deletion. Or maybe erosion. Means it is called pruning. Means why? Because what is the need of the pruning? Means we are simply unwanted. If unnecessary branches are there, unnecessary leaf nodes are there. In the representation, tree representation, we can simply eliminate it. We can simply avoid it or we can simply remove it. Based on the removing process, we are getting the some results. Means we are getting some optimal decision. Why? Because we can reduce some complexity. Why? Because we may reduce the some reducing some unnecessary branches or unnecessary leaf nodes from the tree representation. Automatically reduces some complexity. Automatically reduces some difficulty in tree representation or maybe calculation about the tree. Next one, parent or maybe child node. Means either root node, the root node is the tree is called as the parent node. Means root node is called the parent node. Means where the tree representation tree is represented. So whereas come to this one, for example, this one is root node, this one is sub node. Right. Again, this one. Again. Here, again, here, as well as again here. So here, this node is called root node or parent node. Remaining all these, either maybe this one as well as this one, as this one as well as this one, this one as well as this one. Means when I come to the left side. These are the chain nodes to this parent node. Why? Because this is below its layers, below its level. And these are the chain nodes to the root node. Means that is about the parent. Means the parent node is nothing but root node of the tree, whereas child nodes is nothing but its referent means below nodes. That is thing about the keywords. Means finally 6 keywords is there, as well as one more node is there, one more thing, one more keyword is missed. That is about the decision node in the decision tree. That is about the decision node. That decision node is nothing but make some decisions based on the given data sets and produce some output also. Means whenever we discuss parent node, decision node, automatically we have some databases. From that database, we make some decision. That decision is based on making some decisions based on the some conditions or some rules. That is means separate decision node. Decision node is there in the decision tree representation. Right. Next, what the procedure is there about the decision tree learning algorithm? Means what the procedure is there. First one, in a decision tree for predicting the class of a given data set, the algorithm start from the root node for the tree. Means we are collecting some databases or data sets, and we try to start the decision building a decision tree. We are starting from the root node. As well as this algorithm compares the values of root attributes with the recording means attributed. Means that root algorithm means we are start with the rooting node and we try to follow some algorithm and compare some values, root values, means compare the attribute values one by one. And then based on the comparison, follows the branch and jumps to the next node. Means we can make some decisions. We can make some conditions. Based on conditions, we can move to the one place to another place as well as another place to the another place. Means next node. First node to the next node as well as next node to the node. So for the next node, the algorithm again compares attribute value. Means for that we can try to move to the next node. Again we compare the attribute values based on conditions. It may be go to the further. Means value with the other sub nodes also and move further. Means based on the comparison, we can go to the one by one as well as one by one. Means further extension. And it continues the process until it reaches the leaf node of the tree. Means that process continues until we can reach the leaf node. Whereas come to the decision tree representation condition, whenever we can reach, means here take some decision node, we have one left nodes. Means we only here left side is only limited nodes. But whereas come to the right side node, it contains some decision node, again decision node. Means further extension. Until we reach the leaf node, we can simply stop itself. That is thing about this representation. Right now. So until we can reach the leaf node, then we can start it. Means the complete process can be better understood using the simple algorithm. That is about the simple steps. That is about the first step. Here is 5 steps are there. Basically, mainly 4 steps are important. The remaining 5th one is recursively happening. Right. First step, begin the tree with root node. Say yes. Means we can need some node. It starts with the yes. As well as which contains the complete data set. Means starting with the root node, it is called yes. And it contains the complete entire data set. Means enter input data values or enter attribute values. Right. Next, find the best attribute value in the data set using attribute selection measure. Means from the data sets, from the attribute values, we are select the best attribute value, best attribute from that given data set based on the attribute selection measure, ESM procedure. And again, based on the after selecting the best attribute value, again divide the root node means about yes into the subset that contains the possible values for the best attribute values. Means the third step, we are trying to divide the subset. Means the first one start with the data set value, that's about the root node, yes. And the second one, we are select the best attribute value from the given data set. And the third step, based on best attribute value, we try to divide the subtrees to the yes means root node based on conditions. Right. Next, our fourth step, generate the decision tree node, which contains the best attribute value. Means generate the decision tree node, which contains the best attribute. Means in the fourth step is generate the decision tree node, which contains the best attribute value. Next, fifth one, that is about the recursively make new decision trees using the subset of the data set which is created in the step 3. And based on some all possible values, we try to generate the new trees. Continue this process until stage is reached where you cannot further classify the nodes and call the final node as a leaf node. Means this process continues to start until we reach the final node or the leaf node. That is the thing. These the 5 steps are there in decision tree learning. Right. We are various one more thing is means attribute. We are select the best attribute value when you build a decision tree. We require best attribute value means that attribute value you select the attribute selection. I mean best we can try to express, try to calculate the best attribute value based on the attribute selection measurement or attribute selection process. What is the procedure is there, right? While implementing a decision tree, that main issue is arise to how to select the best attribute. Means whenever start and when you start with the implementation of the decision tree, the main issue is how to select the best attribute value for the root node and for subnodes. Means from the data set we are select the best attribute value for the root node and then for the nodes. So it solves such problems. There is a simple technique is that is called attribute selection measure or the ASM. Means based on this ASM, attribute selection measure or the ASM, we are select the best attribute value from the given data set or the root node. Right. By this measurement, we can easily select the best attribute for each for the nodes of the tree. Means based on the ASM technique, we are select the best attribute value. There are two popular techniques. It is called ASM. Means to select the best attribute value. For that purpose, we have two techniques are there. First one is information may gain, as well as second one is Gini index. Means here two things are there. Based on the two functions, two things, we are select the best attribute value in the attribute selection measurement process. The first one is information gain, as well as second one is Gini index. Based on these two techniques, we are finding the best attribute value. Right. Whereas information gain is the measurement of the changes entropy of the segmentation of the data based on the attribute value. Means the information gain is one type of the measurement. Any changes in the entropy after segmentation about the data set and attribute value. Means information gain is one type of the measurement about to any changes are there in entropy after segmentation about the tree. And according to the value of information gain, we split the node and build the decision tree. Means according to the value of the information gain, there may be either high information gain as well as low information gain. Based on that, we try to design a one decision tree. A decision tree algorithm always try to maximize the value of information gain. Means the decision tree algorithm maximum it gives some highest information gain value. And a node attribute having the highest information gain is the split first. It can be calculated using the below formula. Means how we can calculate the information gain. That information gain is equal to entropy. Means new word is comes to this calculation ASM technique. Entropy of S minus S stands for the sample minus weightage about the sample data as well as into entropy of each feature of the sample data. Right. Then we discuss. Means what is the meaning about the entropy? How we can calculate the entropy value. Means here is entropy is calculated. Means entropy is a metric to measure the impurity of a given attribute value. Means entropy is a metric to measure the impurity of the given attribute value. Means we can what is the impurity is there in the given data set. It measured by the entropy. And it specifies the randomness in data. Means it specifies the randomness in data. As well as entropy can be calculated as entropy of some sample data S is equal to means probability of the S log 2 P of probability of the S minus probability of the no log probability of the no value. Means here is S is where S is a total number of the samples. As well as P of S is equal to probability of the S. As well as P of no is called probability of the no. Means we are calculate this entropy by using this probability about the supporting as well as probability about the not supporting. Means probability about the yes conditions, probability about the no conditions. Or probability about the supporting, probability about the positive as well as probability about the negative. So based on this, we are trying to calculate the entropy in ASM measurement. Means next, Gini index. Gini index is a measure of impurity or purity while using creating a decision tree in CORT algorithm. Means Gini indexing is a measure that is measure the impurity as well as purity while using the creating decision tree by using CORT algorithm. And An attribute with a low Gini index value means an attribute with low Gini index should be preferred for the compared to high Gini index value. Means an attribute low Gini index value should be compared with a high Gini index value. And then it only creates the binary splits, and COT algorithm uses the Gini index to create binary splits. Right. Next, finally, the Gini index can be calculated using the below formula. Means Gini index is equal to 1 minus summation about the J. P of probability about the J square. Means based on this, we try to find the Gini index value. So based on the information gain as well as Gini index, we are select the best attribute value in attribute selection measurement process. Right. Next one is pruning. Means what is the meaning about the pruning? The pruning is nothing but a on-private process. As well as the result about the pruning is getting a optimal decision tree. Means the pruning is a process of deleting the unnecessary node from the tree in order to get the optimal decision. In previously I can say. Why we can use the pruning means we try to avoid, we try to eliminate or try to erase the unnecessary nodes or branches from the tree representation. So automatically get some optimal decision. Or we automatically get some optimal decision tree also. So whenever we can remove the unnecessary nodes or unnecessary branches from the leaf tree representation, that should not be reflected on the main accuracy or main result about the decision tree. Keep in mind, whenever we can start the pruning process. Means elimination about the branches or elimination about the leaf node from the tree representation. That elimination process or the removing process about the leaf nodes or the branch nodes, it should not be affect on the accuracy or the result about the decision tree. This keep in mind. Right. A too large tree increases the risk of overfitting. Means very large tree is automatic some risk is there the overfitting. As well as, and a small tree may not capture the all information from the important features about the data sets. Means a small tree also not suitable to get the all important features. But therefore, a technique that decreases size of the learning tree without reducing accuracy is known as the pruning. Means in large trees, it is somewhat problems overfitting. As well as small tree representation, it should not get the complete information, complete characteristics, complete attribute value, complete features about the data set, attribute values. So we can compare the both either large as well as small, and with respect of the anything means about therefore means there is no change to the accuracy of the databases attribute values in pruning. It is called pruning. Means therefore a technique that decreases size of the learning tree means we can decrease the learning tree size of the learning tree without any reduction accuracy of the given decision tree. It is called pruning. So up to now, still now we discuss about the basics about the decision tree. Starting from the decision tree, as well as in the decision tree we can learn what is the meaning of decision tree. It is what type of technique is there. It is supervised learning. What are the various components are the decision tree, and what is the structure about the decision tree. What are the structures contains root nodes, decision nodes, as well as leaf nodes. When you observe this figure, all leaf nodes, all decision nodes in the same color, as well as all leaf nodes in the same color. Means we can check it 1 second. Means we have some observation. Means about some classification. Simply classified. Means all leaf nodes comes on the one side. Means one color. As well as all decision nodes comes on the another color. Means some automatically represents these are the leaf nodes, these are the decision nodes. As well as root node is represented by the separate color. It is some green. Next, what are the main reasons we can use the decision tree in machine learning approach? First one is it is a decision tree is like a human, think like a human being and behave like a human being in decision making. And the logic also shows in the tree structure. And what are the keywords are there in decision tree algorithm? There is about the decision tree nodes, keywords, decision tree, and root node, leaf node, splitting, branch or subtree, pruning, parent node or child node, as well as decision node. And what are the processes are there about the decision tree algorithm? We can try to explain it. We try to what are the processes are there. First steps are there. First starting with the initialize the root node. That's about the yes. And then we select the best attribute value by using ASM technique. For the best attribute value, we divide the root node into some splitting subtrees. And then the final fourth one is we can generate the decision tree in the fourth step. And fifth one is we can start the recursively until we reach the final decision node. And attribute selection measures. There are some. We are select the best attribute selection measure. Main objective is to get the best attribute value for the root node. So means we are select the best attribute value for the root node and for subnodes. That is about the main theme about the attribute selection measure. For the best attribute attribute value for the root node, based on we can find it about the two techniques. That's about the information gain as well as gain index. Again, the information gain is has somewhat one more parameter about the entropy, and the entropy is and gain index. We discuss about gain index also. We calculate it based on some data. Whereas come to the entropy is mainly measurement about the impurity of the given data set or given attribute values. Whereas come to the gain index, it is measures the impurity as well as purity of the attribute values in the decision tree in COT algorithm and it is index. And finally, we discuss about the pruning of the decision tree. The pruning, whenever you are pruning, automatically is output. That is about getting an optimal decision tree. Means we try to reduce the size of the decision tree without any loss of the accuracy of the decision tree, accuracy of the attribute values. That is thing about the decision tree. Right, ma? Thank you. Thank you, Vanda.
Like, share and subscribe. Hit the bell icon for more updates.